Imagine this for a moment. You send a simple message to your friend saying, I'll meet you at 6. Seems harmless, but what if while that message is traveling through the internet, someone else, a hacker or a stranger, could secretly read it? Suddenly, your private plan isn't so private anymore. Kind of scary, right? Now, think about how often you send messages, share passwords, or make online payments. How do you keep all that sensitive information safe from prying eyes? That's exactly where cryptography steps in, and in this video, we will understand it step by step. So let's begin by taking a quick look at the agenda for today's video. First, we will understand what cryptography actually is. Then, we'll explore the fascinating history. After that, we will break down how encryption works and look at some important cryptography algorithms like RSA, AES, and hash functions. Next, we will see how cryptography is used in real world to keep your data safe. And finally, we will peek into the future of cryptography and the challenges that lie ahead. And trust me, you don't want to miss this. Stay tuned till the very end for some mind-blowing bonus picks, including the best books and powerful tools that can take your cryptography skills to the next level. Watch till the end, it will be totally worth it. Now, before we dive into today's video, don't forget to check out Simplilearn's course. Now, it's perfect if you're just starting out. No math or coding experience is needed for this. You will get self-paced video lessons, hands-on knowledge of encryption, hashing, and digital security, plus a certification on completion. Now, whether you're a developer, a cybersecurity enthusiast, or simply curious, this course will help you build confidence in protecting data in today's digital world. Now, before we officially begin, here's a quick quiz question for you. The question is, what is the main purpose of cryptography? And your options are to make computers faster, to store large amounts of data, to protect information and keep it secure, or to design websites. Let us know the answers in the comment section below. So without any further ado, let's get started. Now let's understand what is cryptography. Cryptography is an invisible shield that keeps your data safe, making sure only the right person can read it. You can simply put cryptography is like turning your message into a secret code. If someone else sees it, it looks like nonsense, but your friend can easily decode and read it. We use cryptography every day to protect messages, payments, and personal information from hackers. So in short, it's the art of creating and solving secret codes to keep our digital world secure. But have you ever wondered how your private messages stay private? Or how banks trust online transactions without seeing you in person? Let's find that out. So now, let's discuss a brief history of secret codes. To understand cryptography better, let's travel back in time. Thousands of years ago, people were already trying to protect secrets. One of the earliest methods was the Caesar cipher, used by Julius Caesar. He simply shifted letters in the alphabet so that enemies couldn't understand his messages. Simple but clever for its time. Fast forward to World War II, the German army used a machine called Enigma, which created extremely complex codes. Breaking Enigma helped change the war and marked a huge moment in the history of cryptography. From secret letters and war messages, cryptography slowly evolved into what we now call modern cryptography, powered by mathematics and computers. Now, isn't it amazing that something so old still is today? So now let's understand how does encryption actually works without any technical confusion. So you can think of encryption like a lock and key. Your message is the lock and the key is what opens it. There are two main types of keys. The first one is symmetric encryption. The same key is used to unlock the messages. This is fast, but both people must somehow share the key safely. Second one is asymmetric encryption. Now there are two keys, public key and private key. The public key locks the message, but only the private key can unlock it. Now here's a question. If everyone can see the public key, why can't they read the message? Because only the private key can open it, and that key is kept secret. So you see, it's that simple. Now let's meet some famous cryptography algorithms that you may heard of. Let's talk about RSA. Now, RSA is one of the most important encryption methods used in the internet. It works by using very large prime numbers to create encryption keys. Now, these numbers are easy for a computer to multiply together, but extremely hard to break apart once they are combined. This is what makes RSA secure. RSA uses two keys, a public key and a private key. The public key is shared with everyone and it is used to lock or encrypt the data. The private key is kept secret and it is the only key that can unlock or decrypt the data. So even if someone intercepts the encrypted message while it's traveling online, they cannot read it without the private key. So in simple terms, RSA makes sure that only the intended person can read the message, even in an open or public network like the internet. Now it's time to talk about our second algorithm on our list, which is AES. This one stands for Advanced Encryption Standard. Now, AES is one of the most widely used encryption methods in the world today. It is used in smartphones, laptops, cloud storage, banking system, and even streaming platforms like Netflix or Spotify. AES is symmetric encryption algorithm, which means the same key is used to lock and unlock the data. Now, this makes it very fast, especially when handling large amounts of information. Now, what makes AES special is that it not only it is fast, but also extremely strong and trusted. Governments, companies, and security experts around the world rely on AES to protect sensitive data. So, in simple terms, AES is the workhorse of modern encryption. It quietly protects your data every time you use a digital device. Then there are hash functions like SHA-256. Now hash functions are different from encryption. They do not lock or unlock data. Instead, they take any input, a password, a file, or a message, and it turns into a fixed length string of characters called a hash. You can think of it as a digital fingerprint. Now, what makes SHA-256 powerful is that even a tiny change in the original data, like changing one letter, creates a completely different hash. And once a hash is created, it cannot be reversed to get the original data back. Many people think that SHA-256 is actually used for Bitcoin, but it's used everywhere. Websites use it to store passwords safely and systems use it to verify data integrity, making sure that data has not been changed or tampered with. So in simple words, SHA-256 helps confirm that data is real, unchanged, and trustworthy without revealing the data itself. So these were some famous algorithms for cryptography you should look up to. Now, let's look at how you can use cryptography in real life. You can interact with cryptography every single day, often without even realizing it. Now, whenever you see HTTPS in your browser, your connection is protected using encryption. That means any data you send, like passwords, messages, or payment details, is locked so hackers can't read it while it travels across the internet. Apps like WhatsApp use end-to-end encryption. Your messages are encrypted on your phone and can only be decrypted on receiver's device. Not even WhatsApp itself can read your conversations, keeping your chats private and secure. Cryptography is also the backbone of cryptocurrency and blockchain technology. Now, instead of relying on banks or middlemen, blockchain uses cryptographic techniques and mathematics to verify transactions and build trust. So in simple words, cryptography works silently in background, protecting your data, your privacy, and your digital life every single day. So now that you have seen how deeply cryptography is woven into your everyday life, let's take a step further and understand how cryptographers actually think. The good news is you don't need to be a math genius. What really matters is curiosity and logical thinking. Cryptography is built on simple ideas like number theory and modular math. You can think of modular math like a clock. After 12, it goes back to 1. This simple concept is powerful enough to create security systems that are extremely hard to break. Then we've got prime numbers. The prime numbers also play a huge role. They are easy to multiply together, but incredibly difficult to break back into their original values. Now, this one-way difficulty is what keeps many encryption systems secure. But here's an important truth. No system is ever 100% perfect. Attackers don't just always break the math. Instead, they exploit weak passwords, leaked keys, poor system design, or outdated algorithms. Now, that's why cryptographers always try to think like attackers first, to find out and fix weaknesses before someone else's does. So here's a final question for you. If security keeps improving, why do cyber attacks still succeed? The answer is very simple. Humans make mistakes, not machines. Now, let's talk about the biggest future threat to cryptography, which is quantum computing. Today, encryption is powerful, but quantum computers could change the rules completely. Now, these machines can process information in totally different way, making them strong enough to break some of the encryption methods. Now, that sounds worrying, but don't panic. This is where post-quantum cryptography comes in. Post-quantum cryptography means creating new encryption methods that are designed to stay secure even if quantum computers become common. Researchers are already testing and improving these algorithms so that our data stays safe in the future. Now, the big question is, what can you do to stay secure moving forward? The answer is very simple. Use strong and unique passwords. Enable two-factor authentication. Keep your apps and system updated. And trust platforms that invest in modern security standards. You don't need to understand quantum math to stay safe. You just need to stay informed and follow good security habits. Because no matter how advanced technology becomes, smart users are always the first line of defense. Now let's move on to the demo part. So now I'm going to show you how to get started with cryptography using Python. We'll go over to what you need to install and I'll walk you through writing a simple encryption and decryption program. So let's dive in. First step is installing all the prerequisites needed. Now, before we start writing any code, there are a few tools that you need to install on your computer. The first one is Python. Now, make sure that you have Python installed on your computer. If not, then you can just download it from the python.org, this particular website from here. So when you scroll this down, you get the latest version of Python. So just click on this link and install it. Now, since I've already installed Python in my system, we'll move on to installing the other libraries. Next one is the cryptography library. Now, this is the most common library which we will be using for cryptography in Python. That will allow us to create work with encryption and decryption. Now, to install this library, you just need to search for terminal from here. Click on open and your command should be pip install cryptography. Okay, and just click on enter. So here, as you can see, it says defaulting to user installation. All right, requirement already satisfied. Now, previously I had already installed the latest version of cryptography. So you can see the version which is 2.22 now. So I've installed my cryptography library using this terminal. You can do the same. It's very easy to use. So now that we have installed the required libraries, let's start writing our code. So for this, you can open any of your code editor. So here I'll be using VS Code. If you have VS Code, you can use that, or you can also use a notebook, Jupyter Notebook as well. So just go to VS Code from here, click on File, and then select New File from here. Write the name as crypto.py, and then click on Create File. Okay, yeah, I'm going to replace it. Now here, we'll just get started with our coding. The first step is actually to import the necessary parts, and the code for this is from Fernet import Fernet. So why are we using Fernet here? Because Fernet is a symmetric encryption system, which means the same key is used for both encrypting and decrypting the data. Now, it's great for beginners because it's simple to use and it secures enough of many basic applications. Next step would be generating a key for encryption. Now, this key is what will be used to encrypt and decrypt our messages. So here's how you can generate it in Python. And the code for this is key is equals to fernet.generate key, and then you can print your encryption key in bracket key. Now, this command will generate a random key using fernet.generate key, where you will be needing this key later to decrypt your messages. Now, it's really important that you keep this key safe because without it, you won't be able to decrypt your data. Now, you can store this file database or any other secure place which you choose. Now, let's encrypt a message. Now we'll be writing a message and then we will encrypt it using the key we generated. Now here's the code. So the code is cipher underscore and then you can give a message. Message is equals to, let's suppose the message is hello cryptography. So it's hello. You can just also put this here. Just click on go and accept. So this one looks better. So we're going to remove from here. And then you can give encrypted message. Just click on this. And then you can print your encrypted message in bracket encrypted message. Now let me explain you this code. Now cipher suit is equals to fernet key. Now this will create an encryption object using the key which we generated. And then the message dot encode function. Now we need to encode the message into bytes because encryption works with bytes and not strings. And then the encrypted message is equals to cipher suit encrypt. Now this will encrypt the message. Now the message is turned into an unreadable format that only someone with the key can decrypt. Now when you run this code, you will see a random looking string as an output. That's your encrypted message. So let us run this code and check. So we'll be running this particular Python file from here. So from here you can see your output, which is your encryption key. This is a random string number, and the second one is your encrypted message from here. Now this random looking string, this is the output, and that's your encrypted message. Let's see how you can decrypt that message. So we'll be decrypting the message using the same key, and here's the code to decrypt the message. So let me just give a comment here to decrypt the message, and the code is decrypted message, which is equals to cipher.decrypt, and in bracket again it's the encrypted message, and then you have to print the decrypted message again in bracket the decrypted messages. So this AI tool really helps you to complete your code from here without actually writing a lot of code. So now that our full code has been done, from generating the key to encrypting the message and also decrypting the message, let us now run the final output and let's just check the result for this. So here, as you can see, you have received three outputs from here. The first one is the encrypted message. One is the decrypted message, which is hello cryptography. Now you could have mentioned any text from here, whatever text you want to be decrypted. Now this command will take the encrypted message, the decrypt one, and it will decrypt it back to the original form. Well, the decrypted message is always in the byte form, so we need to decode it back to the string to print it. Now, the decrypted message, which should always match the original message. When you see these three outputs from here, make sure that this decrypted message should always match your encrypted message from here. So guys, now you have just learned how to encrypt and decrypt messages in Python using this cryptography library. Now, this is a very basic introduction to how cryptography works. Keep practicing with different types of message and keys. Cryptography is widely used to secure sensitive data in real-world applications like banking, messaging apps, and even blockchain. And that brings us to the end of today's video. Let's do a quick recap of what we have covered. First, we have learned what cryptography really is, why it exists, and how it quietly protects your messages, payments, and online activity every single day. We also explored the history of cryptography, understood how encryption works behind the scenes, and looked at how it's shaping the future of digital security. And most importantly, you now know that cryptography isn't just for experts or hackers. It affects everyone who uses the internet. Now it's time to reveal the bonus I have mentioned in the beginning of the video. Now, if you want to go deeper and continue learning cryptography, here are a few beginner-friendly books that you should definitely check out. First one is the Code Book. This book is a fun and engaging journey through secret codes from ancient times to modern cryptography. Next one is Real World Cryptography, a practical guide that explains how encryption actually works in real systems. This one is perfect for beginners. Next one is Crypto, How the Code Rebels Saved Privacy, a story-driven book about the rise of modern cryptography and public key systems. And if you prefer hands-on learning, here are some great tools to practice with. Cryptool, it's a free interactive tool where you can experiment with ciphers, hashing, and encryption techniques. Next one is cryptohack.org, a beginner-friendly platform with puzzles and challenges that makes learning cryptography fun and practical. These resources will help you strengthen your understanding and build confidence in cryptography step by step. And also don't forget to check out the Cryptography full course by Simplilearn on YouTube. It takes you from the basics to advanced concept, all explained in simple and easy to understand way. This one is perfect if you want everything in one place. Now, if you found this video helpful, make sure to like, share, and subscribe to Simplilearn for more such simple, practical tech content. Thank you for watching, and I'll see you in the next video.